friends! Hello! This time we're going to be talking about disc brakes and how to skim them or resurface them when either they warp or they're unevenly worn and have grooves in and so on.
Let's get started with this then. So first thing to do is get the disc brake off the car. I'm going to assume that most people can do this, otherwise just look it up. There's like a million YouTube videos on removing the calipers, changing the pads, changing the discs and all that. In this case we don't want to change the discs, we want to reuse the old discs. They are a big chunk of metal, they're almost always cast iron, and it seems a big waste just to throw them away each time. They're even designed with resurfacing in mind. It's kind of unfortunate that commercial garages treat them as disposable items these days, almost changing them as regularly as the pads themselves. If there's any kind of pitting or grooving, the kind of thing that you could really easily get out in a resurface operation. So I'm going to take you through how to do this. The first thing to do is really wire brush most of the mess off, clean them up a bit, get the abrasive disc brake particles off as much as you can. This inside bit's really important to get clean because that's what we're going to be mounting to.
I had the caliper seized up so the brake pad wasn't retracting properly, and so it constantly rubbed on the disc and that caused overheat and the disc to warp slightly. So one of the first things you're going to need to do is work out if you have enough thickness to resurface the disc. Do a Google or even go to one of the places that does the car part, a replacement disc, and normally in the stats for it will tell you a minimum thickness. I had a good couple of millimeters or millimeter and a half to play with, which was plenty to resurface the disc.
So it is conceivably possible to resurface the discs in a four-jaw chuck using a dial indicator. This is really difficult though, because to make the surfaces exactly parallel it takes a lot of fiddling about. This is what I read and that's mirrored my experience. So the main part of this video is actually going to be making the adapter arbor fixture type thing to mount the disc in the lathe.
I don't know what kind of pipe it was, but it definitely had a thick layer of gunge in there. It's not very nice.
The disc brake fixture is going to be made from that pipe you just saw me turning up, and this big scrap lump of steel. I'm not sure exactly what kind of steel it is, but it turns rather well. The basic premise here is that the disc brake will eventually clamp to this disc of steel which is going to make the fixture, and before each time you use the fixture you'll take a small skim off the plate and that'll ensure complete concentricity. I've got a small section of high tensile steel 16mm threaded rod that I want to use for clamping, and I'm just turning that down so it fits nicely in the hole you saw me drilling in that steel disc just a moment ago.
The welder's on, you can hear that in the background. I've got my ground clamp here. I'm going to weld round here first and then flip it over and do the other side. It's on quite a high setting, so hopefully the wire will plunge right in and we'll get good penetration.
The way I'm doing this is with opposing welds to try and minimise the amount of distortion there's going to be. There's always going to be some warpage doing a hefty weld like this with such thick material.
Going by eye.
Here's that pipe you saw me turning earlier. It's got a nice big 45-degree chamfer in it, which provides plenty of room for a deep weld fillet. Again, firstly, I'm just making some opposing tack welds to hold the part sturdily and in place. Once I've done that, then I can take my time doing some nice inch-long sort of seam welds, both inside and outside of that pipe. Mainly angling the gun so it's going down into the big steel disc, as that's the much more massive of the two. So here it is cooled down and chucked up. The pipe's now chucked in the 3-jaw, and you can see there's a reasonable amount of warpage occurred during the welding. That's entirely expected when you weld something like this. The idea now is that that won't move from the 3-jaw chuck until I've finished resurfacing all 4 of the brake discs of the van. With everything else set, I can come to this ultimate final skim of the clamping surface that we'll be mating with the disc brake. This is a very fine finishing cut with a sharp new bit of carbide. With that done, we're about finished with the fixture, so we can put the first disc on, and it goes on as if mounting onto the axle of the car. So we want that same surface to meet, and just like when you put the disc on a car, it's really crucial to make sure there's no foreign debris in between the two surfaces that are being clamped together, so no specks of rust that can really put it out of alignment and mean that you end up with unacceptable amount of run out in your final disc. So this doesn't need to be ridiculously tight because it'll be turning in a direction where it'll kind of self-tighten anyway, but something decent. And then we need to clock up and check that we've got this on roughly right, and it's nice just to see quite how warped the disc is or how true it's running to that inner surface that would be mating on the axle. With an idea of the high and low spots and the difference between them, we can gauge what kind of roughing cuts we need to take and get started with the actual turning. For this lathe at least, the disc brake's about at the limit of what it could turn without creating a gap in the bed and doing all kinds of extra fettling, which probably would make the project not worth doing. So if you're following along, I guess it's best you check that a disc will actually fit on your lathe before starting any of this project, assuming you have a lathe and you're not just watching out of interest, of course. Once the outside's been turned, we then need to take the finest of skims off this part of the disc brake. This is the part that the wheel will clamp onto when it's on the car, and we need to make this exactly parallel to the inner surface that we're clamping to, and often corrosion means that it's not. So with the finest of skim off that, we can then flip the whole disc and clamp it back onto our fixture, and we know we have the surface completely parallel. And I just verify that by clocking off the what is now the back surface, the one that was skimmed before starting even the braking surface on this side.
No, you're not going to be able to see it, you'll have to take my word for it. Yeah. So I know that's parallel with that edge, which is also parallel with that face and the back face, and that's pretty much got me covered.
So I think it probably is important to state the obvious, which is you do need to use a dial indicator to confirm that all the surfaces are parallel and true. With that done, this can be taken off and put on the car now. First though, I'm just going to quickly rebuild the caliper. This is the seized one. I'm not going to go into the details of this, but it basically needed polishing up and all corrosion run off. It seized because the seal had broken, and so dirt was getting in there. You can get new seal rebuild kits, which is a good way of doing it, I think, because it means you can reuse the meat of the caliper. So I really like this whole process because it means you can almost double, if not more, the lifespan of your typical disc brake. Once you're set up and going with your lathe fixture, it's not too time consuming either. I do feel though that I should give some words of caution here. If you're not confident with any of this process, or competent for that matter, then it's probably best avoided because it really is a safety critical item. I feel a bit foolish just stating the obvious there, but better safe than sorry, I guess. One other thing to note is that the discs always need redoing in pairs, whether that's replacing or resurfacing. You've probably noticed I didn't use any coolant during the cutting, and that's because it's cast iron, so it should self-lubricate. And another note on the cast iron is that it can be really abrasive. It creates very small particles, not like turning steel, so it's well worth protecting your ways and being very vigilant, like hoovering up all the dust. Well friends, that's about it. Do let me know in the comments below if you found that useful, or if you think it's a load of rubbish and you've got a better way of doing it. It'd be great to hear from you. Thanks for keeping me company, and I'll see you next time.